everybody. It's great to see so many people here today, and I'm actually quite impressed by the number of suits that still fit after lockdown. So congratulations everybody on that. Quick introduction. My name is Neil Cook. I'm the Packaging Segment Marketing Manager at the Fujifilm Solutions Group, and I've got today Barry McGregor, who's our Integration and Applications Manager based in Cambridge here. So a very brief outline of Fujifilm Solutions Group. We are a supplier of inks and dispersions to the digital print industry. We supply both aqueous and UV inks, and currently we're operating out 3 production R&D sites, 2 here in the UK, 1 out in the US, plus we've also got the R&D mite that's based out of our head offices in Tokyo, Japan. So, we're seeing at the minute a massive change in the packaging materials that are coming through. We've had the issues mentioned before of plastic pollution, problems around recycling, and we've seen a lot of brands now becoming more creative in how they want to solve those solutions. Now, there is this drive to move away from multi-layers. We're going towards more monomaterials, but then they get also this complexity of these bio-based materials coming into the systems as well, and these biodegradable alternatives. But what we've got to remember as well is that we're here to print stuff. Okay, we want to print ink onto a substrate. And understanding how these substrates are presenting these challenges to ourselves is probably something that we wanted to share. So what we thought today, we'd bring some science to the day. And what we're going to do is Barry's going to go through some of the research that he's been doing, especially on these new materials we're seeing from manufacturers, but also about how things need to be changed and how so we can maintain the print quality going forward. So if we start then, Barry, we're seeing that a lot of these manufacturers and substrate suppliers have differing priorities in how they're trying to solve the sustainability issue. So from the materials that you've been seeing, how's this affecting us in terms of printing?
Okay, before I start into that, I have to declare I'm a nuts and bolts guy. Okay, so I'm into detail, all right, so you have to forgive me if I get into this too far, all right, with it. But part of my work is to try and predict the challenges that are going to face print, and to try and come up with solutions and ways of working so that our print meets its quality requirements. And we've been looking at lots of different applications and lots of different media. And one of the things we do is we contact suppliers and say, what does sustainability mean to you? And the range of answers that we got was quite astounding. Okay, so we're going to go through a few of them, but we're going to start off really, really simply by considering labels. And labels seems to be a really easy target for sustainability. But when you talk to label media providers, their focus is really on the glues, okay, not on the top surface. And what they're trying to do is create glues which are very environmentally friendly in manufacture. So they've got a really good message to their customers. But what we're really interested in is the top surface, okay, with it. And the answer you get is, well, we're going to include 30 to 100% recycled material in the top surface. It'll be no problem, okay. Now, that isn't always the case, and being a details man, we like to drill into what the implications are for our business and for the print formation to understand how does that affect the inks and the properties of the inks that we're going to form in the future. Okay, so to drill into that, I want to give you a little example of how the business works today. I was disappointed I'm only allowed 2 slides in this. I like big slide decks, all right, but we've got an example here of some experiments we run. So typically in the digital industry, we have to corona treat label stock. If you read the published literature, they say you don't have to, okay? However, in practice, we know from our Flexo business that most media does have to be corona treated, and that's to give adhesion, not image quality, okay? So the inks have got to stick to the surface. You corona treat with about 30 to 50 watt-minutes per meter squared to the surface, and that gives you a key, essentially, for the ink to bond to the surface, and you get really strong adhesion, okay? When we do tests of different medias, we do surface energy tests. As you can see here, we've got some results. And these are nominally the same material, okay? They're just coming from different suppliers, but you also know that notice within the suppliers, there's variations in how the media responds to the corona treatment. And as you change the corona dose level, you change the surface energy. As you change the surface energy, you change the dot gain. As you change the dot gain, you change the image quality. Okay, and what that means is we have to essentially create recipes for our different media. And anybody that's involved in the print industry is familiar with this. You know, you get your media, you profile it, you print on it, you get consistent results. Okay, that's what we have at the moment, and that's challenging in itself. Now what we're going to do is throw 30 to 100% recycled media in the top of that, where we have no control over the performance of those. In particular, things that are hidden away concern us, things like plasticizers and things like that, which leach to the surface and give us a variable performance. So whilst we have no control over this, what we're trying to do is talk to the manufacturers of these materials to try and work with them to give them a refocus back into the composition of these materials so that our inks continue working. And if they can't do that, then what we've got to do is understand the implications for our ink performance and try and redesign inks to work on these new materials. So simplistically it sounds, well, we'll just use recycled material in there. It's not as simple as it sounds, and there's a huge amount of work that needs to be done to qualify these materials, particularly on batch-to-batch consistency, okay, within there, and how the materials enter the chain for these kinds of recycled products.
Okay, great. That's right. So if this variability in the material is going to cause us an issue with print labels, are we going to see similar issues, or is it going to be improved when we go to monomaterials and plastics?
Okay, I love the idea of these monomaterials. They're the dream material. You've got a simple material, you print on the surface, what could possibly go wrong? Okay, well, we all know from the attempts to print on foil films, that's a lot more challenging than it sounds again in principle, okay? So by making these monomaterials, are we going to make our life easier? Well, again, the materials providers are focused on three things when they're developing these new materials, and that's on the barrier properties of these films. It's about the sealability of the films, okay? And then lastly, it's about the print on the surface, okay, with it. And their focus isn't necessarily on helping us do our job. Their focus is on making a material which performs good from a functionality side where you happen to print on the surface. Okay? Now the idea of these monomaterials is fantastic. It's a single material, which means it can go into recycling as a single material, and then you can have a cyclic recycling. That's not quite how it looks as though it's going to pan out, because what we're going to do is put ink on the top surface. Okay? But we have to limit the amount of ink we can put on the top surface. That's putting constraints on the ink more than we currently have. Okay? What we've also done by going to monomaterials is we removed any absorption layers from the top which promote the adhesion of the ink to the surface. Okay, so normally you'd have a top coat on there or a receiver layer or something like that. Also, the inks are no longer protected, they're not in laminates, okay, with it. So you can have lamination, but it has to be the same material. So now you've got these sandwiches which are very, very high specification, but the ink has got to perform very, very differently in them. Okay? Now, companies are investing heavily in these kinds of materials, companies like Jindal and such like, and have a look at their websites, and they do talk about print, but it's always from the traditional technology of print. It's not from the new technologies which are going to come through to help recycling by having short runs, by allowing companies to move away from holding large volumes of stock where some goes to waste, you know, those kinds of things. So it's really important that these companies start talking to us in their development process so that then they start generating materials which we can actually bond onto. And you could turn around and say the simplest thing that we could do is corona treat these surfaces. Okay, then we've got a nice surface that we can actually print on top of. Okay, however, by corona treating these materials, we're actually changing the material composition at the top surface. And because they're monomaterials, we don't know how that propagates through, okay, and we don't know whether it actually destroys the barrier function of these films. Now, I'm a bit of a scaremonger when it comes to print. I don't like change, okay, with it. I like to do things, you know, the same time every time. It's the physicist in me, you know, routine, those kinds of things. But we have to embrace this change, okay, with it. And yes, I'm ringing an alarm bell, but that alarm bell may not exist. But because there's no conversation at the moment between the ink providers and the system integrators and the foil providers, it means there's too many open questions, and we've got to try and work together to address that.
Great. Okay, so those are the current materials we're seeing at the minute. You know, we're seeing a lot of talk around pulp-based products replacing plastics. with these new pulp-based materials, what sort of challenges do you see we having with those?
So I get very excited about these. Okay, so it doesn't take a lot to excite me, as you probably guess. With it. So doing a lot of search, I get to look at what's coming through, and we've heard from various people. We like traditional materials because the recycling chain works for those at the moment, and I get all of that. My job is to look further ahead and say what's coming through, where are we going to go? And pulp-based materials seem to be quite exciting opportunities. Now, I'm not saying they're going to replace everything, okay, but there's some interesting concepts coming through, and there's a few on here. Okay, from companies which seem to be making a mark and creating opportunities. Now, if they've got companies like PepsiCo involved in the developments of these, they're serious propositions, all right? They're not, let's have a look at a lab scale, okay, and then we'll carry on doing what we're doing and have a small volume on something else. These are real opportunities with real investment behind them. So there is a drive to establish whether these technologies are possible, okay? So the bottles are an interesting concept. I never even thought that you could make paper bottles. It just seemed like a foreign concept to me with it. When you look online, and do look online at these, because they're really interesting. When you look online, you'll see that they're actually made by a very interesting process. Okay, so it appears, and again, we have no conversations with these, but it appears that they're centrifugally compressed, okay, and then a barrier material is applied, and I won't mention which company is doing that, but a barrier material is applied to give it the water barrier effect, and it's all baked off, okay? And the company there, Pulpex, are claiming to have the first PET-free bottle, okay, which is quite revolutionary. Their focus is getting it to manufacture level, which is fantastic, and they've got all these pros and cons that they talk about on the website. One of the big pros is you can have this beautiful embossing on the surface, your branding and such like. What it doesn't address is the printability, okay? So yeah, you've got your embossing, you can have your logo, but where's the information, the legally required information about the product that goes inside of that, okay? So that information's got to go with the product no matter what. So the easiest thing you do is slap a label on it, all right? But labels tend to be plastic, so that industry's got to change. So we've got to move to paper labels. Sounds really interesting, doesn't it? So it's really easy, okay? It's not, because those labels have got to resist chafing in transit. Okay, so they've got to be really, really strong labels. They've also got to be able to support the fine text that we need on these products, for people to be able to get the massive amount of information that they need on there. Okay, so there are challenges on putting labels on. Also, it goes against the waste management side of things. We saw the 4 R's there. We should always remove before we reuse. Or even recycle, remove before recycling, with it. If we're slapping a label on there, we're going against that. So could we do direct to object, in this case? So if we're going to do direct to object, then we have to be careful about destroying the properties of these bottles by absorbing material into them, which degrades their structural stability, because nobody wants to drink a Coca-Cola bottle where the high print areas are leaking all over your shirt. With it. So those kinds of problems, that we've got to address with it. The biggest problem for me in this area is manufacturability. Direct to object is still in its infancy. There are some great examples of it and some really, really high speed stuff going on, but it's not at manufacture process levels. And there's other companies, such as the company shown on the right there, Pulp, who are looking at making trays which will allow us to do things like in-mold lamination of labels. And again, that requires new ink technologies to be developed, where we would have to create prints that can be printed on very, very thin films, suspended, and then compressed into the tray during manufacture. So the print becomes part of the product itself, okay, and therefore more robust.
Thanks, Barry. We have to cut you off, unfortunately. We're running
sorry.
out of time. I keep getting the nudge from over this side.
Barry's just so excited.
I know he is.
I do get excited, yeah.
So. You talk at night, this is what...
It drives my wife nuts. Yeah.
So just to conclude then, really, you can see that this recycled, the new ranges of packaging is going to cause us some real challenges within the printing industry. We need to understand how these materials and the substrate are going to affect the digital print. We need to understand how that decorative level is going to be applied. We want to understand about the other production processes, as Barry mentioned there, and also we want to understand where this is going to take place in that production cycle. Without doubt, we understand that digital print is a sustainability enabler. there's improved production efficiencies, shorter supply chains, possibility of new markets that all definitely fall in that area. But developing isolation is just going to cause us to get there in a lot longer time. If we work closer together, speaking to people who aren't necessarily within our initial core group of contacts, we're actually going to get more information to allow us to develop products more efficiently, faster, and more importantly, will meet those customer demands. Okay. Thank you very much.